Mechanical properties of fluid. So the term fluid that refers to a substance which has no definite shape of its own and assumes the shape of the container or the containing vessel. So it has the ability to flow. So this is what is fluid. What is fluid thrust? It is the total normal force exerted by a fluid on rest of a given surface in contact with it. That is called thrust of the fluid on that surface. So this is always normal to the surface. If you see, this is a cube and the force by the fluid is always normal to the surface in contact. Okay, so please note that. What is fluid pressure? The thrust exerted by a fluid at rest per unit area of the surface in contact with it is called fluid pressure. So we know pressure is force by unit area. So that is what is full fluid pressure. So here the thrust, that is the force. Okay, thrust is nothing but fluid thrust, that is force in per unit area. So that is what is fluid pressure. SI unit of pressure is Newton per meter square. How do we write this? Because pressure is equals to force by area. So unit of force is Newton, unit of area is Newton meter square. So it is Newton per meter square or it is Pascal. How do we write the dimensional formula? For Newton it is mLT power minus 2. That is mLT power minus 2 by for meter square it is L square. So it is m L power minus 1 T power minus 2 and it is a scalar quantity. And we should know the relation between atmosphere and Pascal, bar and Pascal and torr and Pascal. 1 atmosphere is equals to 10 power 5 into 1.013 Pascal. 1 bar is equals to 10 power 5 Pascal. 1 torr is equals to 133 Pascal. So now let us consider a liquid of density rho contained in the vessel. So the C and D be two points inside the liquid at a vertical distance h. Okay, h height. Let us imagine a cylindrical column of the liquid of cross sectional area A, and such the points C and D are lying at the centers of upper and lower faces of the cylinder. Now, how do we write the weight of the liquid in the imaginary cylinder column? That is mg. So we should write it is volume into density, that is mass into gravity, because it is weight. Now, what is the volume? It is the volume of cylinder, that is area into height. What about density? It is rho, I have already told. And what about g? It is, yes, gravity. So it is A h rho g. So this is the weight of the imaginary cylindrical column of water. Now, this weight, if you see mg, it acts vertically downwards. We have assumed here the density of the liquid is uniform and does not depend upon pressure. So this is true for liquids, okay, which are practically incompressible, but it is not for gases. Okay, now let us consider P1 and P2 be the pressure at point C and D. Okay, P1 is the pressure at point C and P2 is the pressure at point D. Then what is the force on the upper surface of the imaginary cylinder? It is P1 into A, because we know force is equals to pressure into area. That is, pressure is equals to force by area. From that I have told. So force on this upper surface is P1 into A, and that is acting vertically downwards. And force on the lower surface is P2 into A, that is vertically upwards. Why do we write it as vertically downwards? It is vertically upwards because the force on the surface, which is in contact with the liquid, how will be the force? It will be normal to the surface. So here also it is normal to the surface. So that is why we have told it like this. Okay. Now, yes, P1A is towards downwards and P2A is vertically upwards. And if you see the horizontal forces, so there is a horizontal force, it will be like this, 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 and here it will be like this. So it is mutually balanced. Okay, so there is no need to talk about that force. Since the cylinder or the liquid column is in equilibrium, the net force must be 0. So here it is in equilibrium. Okay, now how do we write the equilibrium condition? We have to write the total upward forces is equal to total downward forces, so we can write it like that. So the total forces which are acting vertically downwards is P1A and mg. So P1A plus mg plus What are the and other forces? P2A, which is vertically upward. So I am writing a negative sign. So minus P2A equals to 0. Now, what about mg? The value of mg is ah rho g. So I am substituting it. P1a plus ah rho g equals to P2a. So P equals to, that is P1 minus P2 equals to, so we are cancelling a, okay. P equals to P2 minus P1, that is equals to h into rho into g. So the pressure exerted by a liquid at a point depends on the vertical depth of the point and density of the liquid only. So what we are saying, so here this gives us the formula for pressure. Okay, pressure at a point which is at certain height from the surface. Okay, then that pressure is equals to h, that is height, into rho, that is density of the liquid, into gravity. And here you please note, it is not dependent, this pressure is not dependent upon the shape of the container or the amount of liquid in the container. No, it is not depending on all those things. It is only dependent on the vertical depth of the point and density of the liquid only. Okay, yes.